thinks that this is the most important lesson I'll teach you this semester? I bet you if you walk down the street or you walk through Walmart or met anybody doing anything in the world, they would say, Mr. Todd, why aren't you teaching them more of this? Okay? And I hope by the end, you won't be able to disagree that this is the kind of thing that people do have to be able to do. Okay? Now, there is some quirks to it, but I hope by the end that you're sort of getting, no, not sort of getting, really getting how this relates to what I was doing yesterday. That is, if you've been liking cross-multiply, it's going to rear its head. It's going to appear in this lesson. Cross-multiply is vital to what we're doing here. Now, there's a little problem that we got to deal with. We got to talk about using imperial measurements. Now, this isn't where your slide starts, is it? I think I'm on the wrong page here. Doesn't your slide start? There. Isn't that what yours says first? Yeah. Okay, let's just talk about this. I hope you've heard of a lot of this, but listen to my version of it so you're ready to go. Metric and imperial measurements. Let me just go back and try and explain how this mess started. Imperial measurements came first. It was based on, I believe this, that somebody went, well, we got to start measuring things. What will we measure them by? And somebody went, well, how about we measure them using our feet? I don't know if you know this, but my foot is almost exactly 1 foot long. And I remember finding that out and going, oh, I get it. 1 foot is about the average person's length of their foot.
Wait, a foot is a ruler?
That's about a foot. Yeah? An average person's foot. If you've got a pretty long foot, you might find it's more than 12 inches. These tiles are one, go ahead, drop your ruler on the floor there, and you'll notice they've made these tiles exactly 1 foot. Now, as long as we're at it, you don't do this, and don't tell anyone I did this. And I won't mention what I'm doing on the video, so no one knows what I'm doing. Let's just take a look. 2 feet. Those tiles are 2 feet wide. So there's something standard about feet. Somewhere along the way. Now, the Americans love this. They stick with it. They didn't like the metric system. Whereas the Europeans at some point, the Europeans were a little more thoughtful. They went, can we do something better, please? Because listen to how this happens with feet. Just to be clear. A mile is 5,280 feet. Who would come up with that? It's ridiculous why someone would choose that. A yard is 3 feet. There's some ridiculous stuff about the imperial measurements, but it served humans well for a long time. It really did bring us out of the dark ages that we could measure things in a standardized way. And the reason it's called imperial is because that was as the imperial kingdoms spread across the world, they brought this measuring system with them. Okay? Somewhere along the way, somebody went, hold on. Let's use our brain a little bit and use something easier to work with. And that's what you learned in school, was metric system. A little easier to work with. It uses millimeters, centimeters, meters, kilometers for linear measurements. Hopefully you've heard of all those. Hopefully those sound a little bit familiar. And common abbreviations are mm for millimeters, cm for centimeters, m for meters, and km for kilometers. It could be when you see km, you just automatically say kilometers. You're so used to it. Jackson, question.
I thought of you this morning, and I kept my notes out just in case if you wanted your greens.
Imperial measurements. Have you heard of these names before? How many have heard of inches before? Yeah. Feet. Yeah. Yards? A little less common, but yes. Miles? That's what imperial uses. Now, the short forms for inch. They use a double quote. 4 inches, they use a little double quote. They like that as a short form. Now, I need to tell you. I'll get sidetracked for a minute on a Friday here. I'm not bad at home improvements. Not bad, just because I'm old. That is, if I had to replace a pipe that was leaking, I could do it. If the drywall is broken, I can repair it. Electrical, some wires need replacing. Mostly I can do it. Drywall, no problem. Ceiling fan, yep. I don't like doing it, but I can do it. This ceiling here, this drop ceiling here, I've installed one of those before. It's not particularly difficult. Tiles on floors, in my lifetime, I've done it. I don't like doing it though. And there's this guy I call, he's a friend of mine. When anything's a little bit difficult or would take me a little bit of time, and I call him, I had a pipe in my wall that was leaking. So imagine just a wall in your house, and I looked one day and there's water, like it just wet, and then there's water pooling up at the bottom. The shower pipe had developed a very small hole and it was spraying water out inside the wall. Well, he came and here's what he does. He cuts the whole section out of the wall, pulls that out, so he can get to the pipe, gets in the pipe, cuts the piece of pipe out, replaces it with a new piece of pipe, solders it all back together, tests that out, and then replaces the drywall. This is the kind of job he does. He's multi-talented. He can do plumbing, he can do drywall, he can do painting, he can do a little bit of everything. He might be the happiest person I know. He loves his job. He come walking in, he wasn't stressed, he looked at it and went, huh, and he got out his saw and he sawed it out. He measured the things out, went to his truck, got the piece he needs, soldered that together, put it all together, said, yeah, it's good. Gave me a bill. I was happy to pay the bill. If you've never had water leak at your house before, you don't know how stressful it is. It's completely scary. It might be outside of your toilet backing up, it might be the scariest thing that can happen in your house, is when there's water leaking everywhere. So I was happy to pay the bill. So some of you who don't know what you want to do with your life, shh. If you really don't know what you want to do with your life, one of the trades is a great choice. Just the ability to fix things around the house. You'll make lots of money. You'll probably make more money than me if you want to work hard. And if you want to work for it, you'll probably make more money than me. You'll probably enjoy the job because you get to go in and fix things all the time, and you make people happy. And you can make loads of money if you want. If you're going to work in the trades, you'll get used to inches, and inches is the double quote. You see the little double quote there? Whereas feet is a single quote. So if you want to do 5 feet, you do one little quote there, one little notch. Makes it easier. Instead of writing 5 feet all the time, they have a short form for it. Yards, they always use YD for yards. How long is a yard? Does anybody know about how long a yard is? It's 3 feet. It's about the same as a meter. It's not exactly the same, but it's pretty close. So a meter stick and a yardstick, they're pretty close in length. Do your teachers have a yardstick or a meter stick? Like it's about this long? Yeah? Wooden stick. When you first look at it, it's hard to tell if it's a yardstick or a meter stick because they're both the same length. Yeah? You can do combinations of units. Who's the tallest person in the class? Declan might be.
Alex.
Anthony maybe. Alex might be. Alex, how tall are you? 6'5". So this is 6'3". So if you're going to write it in Imperial measurements, we always say 6'5". This is how they write it in Imperial. 6 with one quote, then 3 with a double quote. That's how you technically write it. Yeah? Now, Imperial uses fractions instead of decimals. That should get your attention. You're like, hey, fractions. And that's what I want to talk about first today, is the fractions that Imperial measurement uses. You can look at your ruler, look up and down, but here's the type of things they do, all on one ruler. See? Shh. See this ruler? 1, 2, 3, 4. Yours looks a lot like that. It might not look identical to this because there's different versions of it. But within this ruler, they've got all the possible fractions. But it's tough to look at when you first see it. What I want you to focus on, and I'm going to put a green line right down, what I think is an important line in understanding this. What did I say, green? Green line, right there. I just want to talk about that line right there. The biggest line you see between 0 and 1 is the half. So that's a half an inch. And you see, I got a little separate picture out here. I don't know how good this picture is. I don't know how helpful it is. But the line right in the middle divides this thing into halves. The line between the half and 0 is the quarter line. But not all rulers make that one a different size than the other ones. You just got to look at it and sort of count at it. Construction people are very good at this. They can just look right at it and they know which one's which because they do it all the time. But for us, it's going to be a little difficult. We got to count these out. So who wants a shot at what this next one is? If that's a half, that's a quarter. What's this one going to be? It's an eighth. And then the smallest one on these rulers is a 16th. I have seen tape measures with 30 seconds on them before for people who are doing really accurate stuff. Woodworkers who are really building tables and stuff like that, they want really specific measurements. But yours, let's look at yours now, the one I've given you. And I can't see it very well without my glasses on, so I'm going to put it up on the board here so I can look. Oh, first of all, I got mine upside down for imperial measurement. Do you see? I got centimeters up at the top there. I got to flip that over. Yours says inch on it. Do you see it there saying inch? And I think it's in red on your ruler, is it? Yeah. Now, I can definitely see the half on there, but do you see on yours, it's a little harder to see the quarter, because it doesn't stick out, then eighth, then 16th. But those are 16ths. Each one is a 16th. So let's try on my ruler on here to see if we can label these. I've already labeled this one. This one's a 16th. This one's a quarter. But now we need someone who's pretty good at these fractions. On mine, on my sheet, not on your ruler, what's this? Right there. It's hard. To help, he's trying to figure it out, but to help, how much is every 2 lines? Look right here. It is 5. Okay, forget what I was saying. Let's find out what he's talking about. How did you figure that out that was 5/8? He did it pretty quick. He knows something about the situation.
So I just knew north.
What did you know? How did you know?
I don't know. I just know. My brother always tells me to take that. So I just.
Oh yeah, he's worked with it. That's what I was saying. Tradespeople don't find this particularly difficult because they just work with it all day. By the time you do a bunch of measurements, you get used to it. It'll be a little harder for us because we're not going to do it all day. We're going to do it here and there. So I'll give you a strategy, okay? Here's my strategy. I look back here and I go, well, 2 squares is 1/8. So I just count every 2 squares. There's 1/8, 2/8, 3/8, 4/8, 5/8. New strategy. 1/2, if I was counting in eighths, I could count that as 4/8, and then that one's 5/8. I told you, it's not going to be easy to figure these things out. Although it's one of those things that after you do a few of them, you're like, okay, I got it now. So let's not give it too much credit. It's just a ruler, after all. Let's not give it too much credit. So let's take a second to think about what this one is. Right there. I'm going to put a question mark over it. How much is that? Don't say it out loud. Just think for a second. How much is 2 lines? 1. I agree with the 1. That's the whole number. It's at least 1 inch. Then how much more? How much is 2 squares worth? See, this was 2 squares. Or sorry, 2 lines. How much is 2 lines worth? 1/8. I love the way he's saying it really slow. Because he's like, is it 1/8? And that's what you like. Let's say you get a job, a co-op job or something like that, working at a company that's measuring things. They're going to freak out when you can't do it. They're going to be shocked that you can't do it. Because they're like, why aren't you teaching more of this in school? I'm like, well, we got a lot of stuff we got to teach. That's all I can tell you. But by the afternoon of your first day, you're like, okay, I got this. It doesn't take long. It's not impossible. It comes down to going, how much is each line worth? Each single line's worth a 16th, but if I'm going to do 2 lines, it's an 1/8. So this is key. Right here, what's going on over here is key to understanding what's happening. All right, let's try this one right here. This is a very difficult one. Well, let's get the leading number first. What's the number out front? It is not 2. I haven't got all the way up to 2. This is still 1 and something. 7 over 16, he says. Let's see where he's getting that from. Each line is a 16th. How many lines is it? 1, 2, 3, 4, 5, 6, 7. Is there a faster way to do that? Only familiarity. Familiarity. When you've seen a bunch of these. But can you do the next one now? In sixteenths? I'm going to do it a different way now. That'll be 8 sixteenths, 9 sixteenths, 10 sixteenths. It is. The answer is 10 sixteenths. But we wouldn't write 10 sixteenths. It'd be 5 eighths. You're like, oh, here we go with the fractions, Mr. Todd. Yes, but only even fractions. So whoever came up with this system isn't there to completely torture us. There's no thirds here. There's no sevenths. It's all halves, quarters, eighths, and sixteenths. That's all. All right, this is a tough one. One little line, less than 2. What's the leading number? 1. 1 and something. How many sixteenths? Now I'm going to count it out for you, but hopefully somebody...
17. Or I meant
No, hold on. You're right on top of it.
I meant
15. Yeah, he's right. Do you see me react as soon as he said 17? I'm like, he gets it. But you just went 1 too many. 1 less. Yeah, 15, 16. He stopped me before I counted them, right? Because he knew. You don't have to count these. And that's what I was talking about, the familiarity. Once you've seen it a couple times, you're like, oh, I get it now. All right, let's do the next one. We'll just keep cruising along here and just try and get familiar with them. What's going to be the number? What's the whole number? 2. Now it's 2. And if it's a little line, just count the lines. How many lines? 1, 2, 3, 4, 5, 6, 7 sixteenths. You might actually find that the little lines are easier. You might. Always going up by sixteenths. Right? That's where the familiarity comes in. You're like, oh, well, if it's always sixteenths, watch this. I'm going to write, I think, not a right answer. It's a good answer, but it's not a great answer. So say you're at your new construction job, and they say, go measure that, and you measure it, and you go, okay, Mr. Todd said count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sixteenths. It's correct, and your new boss is going to be like, hey, come on. Come on. 12 sixteenths, 3/4. There's a better answer. Could we have got there? Yes, but not by counting sixteenths. We had to count quarters. 1, 2, 3/4. So you got either choice, depending on what you want to do. They're all sixteenths, but many of them reduce. Most of them reduce. All right. Is this one going to reduce? And if you've got a good ruler, you can tell if it's going to reduce because it's got the bigger lines on the ones that reduce. Yours doesn't have all of those. But who wants to take a shot at this one? 3 and what? How many lines? No, how many lines over 3? Yeah, 3 and 3 sixteenths. That one doesn't reduce. Now I encourage you to go, because it's exactly right.
It's going to be 16 every time.
Yeah. It's the even ones that reduce. So the system isn't as bad as it looks.
I already know how to do it.
Yeah.
Because I'm a construction.
Yeah. And how long does it take, really? It doesn't take many practices. Like, I would say by the end of your first day working with this stuff, you're like, okay.
Once you actually just understand that it's just the ticks inside of it.
There's just the ticks inside it. Oh, perfect phrase.
It shows you what it is.
Yeah. So let's do this one 2 eighths, the last one on this sheet, the last one here. I'll do it with sixteenths, and then we'll see if somebody else can do it without the sixteenths, okay? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixteenths. 3 and 5 eighths. Could I have counted it with eighths? Yeah, I could have. 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths. The other thing that'll happen, and you'll get used to them. You'll start to memorize them. Oh, 5 eighths is the eighth right after the center. But only familiarity will do this. It will be annoying for us. Because like if right now I said, okay, let's go do this for 2 weeks. Wouldn't be long before you think it was easy. But don't use my reference here when you're doing them to go, okay, is this 16ths? Is it eighths? And if you're stuck at all, just count the 16ths for now till you get used to it and just reduce the ones that need to be reduced. All right? Okay. Let me be clear. After finishing cross multiplying, on a scale of 1 to 100, I hope you understood it like 70 or more. You're like, I sort of get this. This is more like a 50. You're like, I can take a shot at it. I'm out of the way. I'm ready. Okay. Do you need more time on those? Please be aware, if you ever go into this, the people that do this every day are going to be shocked when you don't know all about this. Because it's not, we don't teach it very often in school. They might be the opposite of nerds. They're like hands-on workers, right? They know their stuff. They know their trade very, very well. Yeah. They know how to build stuff and fix stuff as good as I know how to do math. Like, let's not underestimate their skills. They've got mad skills. Yeah. All right. Take a shot on your piece of paper. It won't work for me because mine's on a giant screen here. Take a shot, and I'm going to do it on my sheet of paper too. Let's all try to measure that line, but it says to the nearest half. To the nearest half inch. We're not trying to get too specific here. Just find the nearest half when you measure it, and we'll just call it the nearest half. Put the 0 at the start of the line. Make sure you're using inches. It's really close, isn't it? When mine doesn't look, it's really close to the half, isn't it? Yeah? Do we agree? It's really close to that. It's not, I don't got it right on. But they only want a nearest half anyways. And depending on what you're building or working on, maybe nearest half is good. I know in plumbing, nearest half is fine because you usually put a coupler on there anyway, so nearest half is more than is plenty close. What's that? We're doing nearest half. So this one was nearest half. On yours, I know it's not on mine. On mine, it's like 3 feet long. But do you see how it's 4.5 inches?
Yes, sir.
You could write 4.5 inches, but anyone want to take a shot the fancy short form way? How do we do inches? 2 of them. Yeah, you can write inches. I'm not trying to convert you. I'm not. You go ahead and write inches. I just want you to know that when you go out there, after, right up there, 2 little slashes like that, just a little quote saying, not feet, inches. Yeah? A single one's feet. Okay, what's the next one say? To the nearest quarter. This time we're in quarter inches, so try it out. See what you think the nearest quarter is. I know what I think it is. You're not going to be able to do it playing on your phone. You have to pick up the ruler.
Katie what to do because she can't see the She doesn't know what's going on because she can't see it. So I'm telling her.
What did you get? 1 3/4. Yeah, you try it out. Stare at it long enough that you can see how that's 1 3/4. And this time I'll write inches just to make you feel better that it's okay to write inches in this class. But be aware that that little double slash means inches. Jackson.
Can you see how I got 1 6/8?
1 6/8 is a good answer. There's nothing technically wrong with 6/8. But fair warning. But it is. Yeah, let's look at it. Let's look at 1 6/8. Both 6 and 8 are even, so I can divide those both by 2, and I get 1 3/4. And this down here, I'll use the short form. The short form is what you'll see most places. Yeah? Like when you look at a tag on something that you're going to buy, or if you're going to look at something, they usually use this for inches. Yeah?
Is the decimal like for like if I
It's not technically wrong, but it's not what will be used for these. They won't use decimals. They'll use the fractions. They'll just go the nearest one. They'll go, oh, about 1 3/4. They'll go 1 7/8. Yeah? It's a pretty good system. It's not as bad as it seems. The metric people put this down, but it's not bad to work with. So here's some conversions. You do not have to memorize. When you go into a specific field, you might want to memorize some of these, but here's a measurement chart. So this will always be available to you. And it says 1 centimeter is 10 millimeters. Have you seen that before? 1 centimeter is 10 millimeters? 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. 1 foot is 12 inches. Did you know that one? Did you know 1 foot was 12 inches? Yeah. 1 yard is 3 feet. We saw that earlier. And I mentioned this. 1 mile is 716 yards, 1,760 yards. What? Why? What an awful choice that was. Somebody just must have decided, oh, let's measure to my house. We'll use that as a mile. Like, it just seems ridiculous. And then here's the ones imperial to metric. 1 inch is 2.54 centimeters. 1 foot is 30.48 centimeters. 1 yard is 0.9144 meters, and 1 mile is 1.609 kilometers. Most of the work we'll do is with these. You don't have to memorize them. You have to be able to look them up and use them, and let me show you how you use them. You're going to like this. You're going to like this. I swear you're going to like this. Hardware stores sell screws using imperial measurements. A wood screw is 2.5 inches long. Convert to centimeters. Okay, wake back up if you've fallen asleep. Here's what I really want you to be able to do today. When you get a question like this and you go, okay, I want to convert to centimeters from inches. Underline both the measurements in the question. That is step 1. Then go to your chart and look around until you find the conversion from inches to centimeters. Look through. Don't trust me. Look through and see if it's there. Do you see it?
Yes.
What is it?
Internal system.
Yes, but I want the one that converts inches to centimeters. Look down the page until you found the relationship between inches and centimeters. There it is. So I'll just put a little star beside it. And now I'm just going to go and write that on my page. But I'm going to write it in a specific way that hopefully some of you go, ow, I know what you're going to do here. Watch. Okay, 1 inch is 2.54 centimeters. I've made it into a ratio.
Wait, are you dividing it?
Hold on. Just hold on. I'm almost there. Now, as soon as I write it as a ratio, I want to give you an image to think about. I'm coaching an 8-year-old hockey team. You should see this. It's the most amazing thing you ever saw. The buzzer goes after 2 minutes because they can't change on the fly. The buzzer goes after 2 minutes. I open the door and they come flying out. The door of the hockey rink and they come flying on the ice. They fall down. They just come charging out. Do you have the image in mind of these 4 hockey players tripping over each other? A big pile of hockey players just outside because they come out and they're like ready to go. They want to go play hockey. As soon as you write this as a ratio, everything I've taught you this chapter comes flying out onto the ice. Goes, hey, put me in. Because I put 1 inch is 2.5 centimeters. What I want to know is, if I have 2.5 inches, how many centimeters? Now just stare at that for a second. Really stare at that for a second until you hear a clunk in your brain where you're like, wait a minute. I know how to do this. Can we do the butterfly? That's exactly what I've set up here. All measurement conversions can be done using the butterfly, the cross multiply. X times 1 is 2.54 times 2.5. Now, what do you want to do with that 2.5? We got some choices here. We can let our calculator handle it. We can easily put it as a decimal. 2.5 turns into a decimal really easy. Does anyone know the decimal?
6.35.
Wait, oh yeah, you're probably right, but 2.5 as a decimal.
2.5 is a decimal.
2.5, okay? I was hoping that most people would be like, well, I can just do that as 2.5. They said 2.5, but that's a pretty easy one to do as a decimal. Now, you're like, well, what if I didn't know? I didn't know that one. Well, then in your calculator, you type in 1 divided by 2, and it would give you the decimal part of that. We're going to centimeters anyway, so we can go to decimals. Does anyone have their calculator there and going 2.54 times 2.5?
Want to go on, get it?
6.35? If your boss said, go buy some 2.5-inch screws, and you got to the store and nothing was in inches, what you'd be looking for would be screws that were about 6.35 centimeters. That would be the measurement on the metric box. It doesn't really play out like that, by the way. Lowe's and Home Depot know
What do they just have both?
it'll have both on it. So why do we really care about this? Say you go to your toolbox. That's not a nice box. You just got random screws. You go, okay, so I need a 6.35 centimeters. Okay. I hope you're like, oh, okay, well, this is okay, as long as I know how to set it up. I wasn't really paying attention when you set it up. Do another one where you set it up first. Okay, here I go. So only 2 more to go and I'm done. Suppose Mary is 1.4 meters tall. How tall is she in feet? Underline the 2 measurements, meters and feet. I need the conversion factor from meters to feet. I go back to here and I look for meters and feet. Do you see meters to feet anywhere there?
No, I do not.
I do not. I do not. It's not there anywhere. What am I going to do?
A yard to a bigger one. We know 3 feet is a yard. Is that right?
Say it again.
So 1 yard, there's a yard in a meter, and we know 3 feet is equal to 1 yard.
Oh, maybe we could use that. Let's get it to yards first, he says. Right? So we need the 1 yard is 0.9144 meters. 1 yard. I don't know why I wrote it like that. One yard is 0.9144 meters.
Oh, you do not have to be doing all this stuff with these answers.
Hold on. You wait until I finish this and then tell me what your idea is, okay? I'm trying to do it with butterfly method. There are other ways to go. Right? So in just a second, I want to hear what you have to say, okay? 1 yard is 0.9144 meters. I'm looking for how many yards is 1.4 meters? Notice I wrote the units there. So I keep track of where to put things. Yards over meters, yards over meters. Now I can do cross multiply. (0.9144x) equals 1 times 1.4. So what's the opposite of dividing, I gave it away. What's the opposite of multiplying by 0.9144? Divide by 0.9144. And even I just went for a calculator because there's no way I'm doing this in my head. $1.28016. 1.28016 what? What did I just convert it to? No. Yard. That's it, yards. So now how do I get to feet? Do I divide it by 3? 1 yard is 3 feet, so it's actually multiplied by 3, isn't it? But that's a decimal. Feet isn't in decimals. So if I want the inches, I got to go 0.84 times 12 to figure out how many inches we're talking about here. And I get 10. So it's about 3 feet, 10 inches. Does that fit? How long is a meter? 100 centimeters? Like it's like about this far? Does that look like about 3 feet? Sort of fits with our experience. That's about 3 feet. Because a tall person's around 6 feet tall. I'm not quite 6 feet. Like I'm just short of 6 feet. It's heartbreaking. 5'11" and 5'8" or something. It's ridiculous. Painful. My big padded shoes, maybe I'd make it, would I? Matching shoes today. That's right. Do we have another idea? Did you have an idea?
I don't really know how to explain the way I do it. I don't know how to explain it. I just do it differently.
Okay. There are other ways to do it. I'm only trying to bring in what I already have. Yeah. Yeah. It could be as easy as just dividing or multiplying by the right thing, as long as you know what to divide or multiply by. No question about it. A little more experience here, and we can maybe simplify to that method. Let's do one last one. Am I right? There's one last one to do? In fact, let's try right now. I'm going to do this 2 different ways. I'm going to do it my way, and then probably the way he's doing it. Probably. What is this question trying to convert between? What are the 2 measurements? Miles to kilometers. And then we go to our chart and see, is there a nice miles to kilometers conversion? And the answer is there one for miles to kilometers?
Yeah.
Yes. Good news. 1 mile is 1.609 kilometers. If you get that, you're happy. Because they told me it was 350 miles. And I want to know how many kilometers. If you set it up that way, you can use butterfly method. You can use what we've been calling cross multiply. Works every time. But I'm going to ask, see if you can explain. Are you doing it this way? Or are you doing another way? Oh, you've already moved on. Can I look at your page and try and explain what you did? Oh, yeah, okay, I love it. So you cross multiply here. X times 1 equals 350 times 1.609. Is anyone doing these without writing the butterflies anymore? Yeah, some people are. Yeah, that's fine. We only write this when we're first getting used to it. Circle those 2 like that. And then X equals whatever 350 times 1.609 is.
217.5.
No. Type it in again. 563.15 kilometers. That's not what you did. What did you do? Tell us what you did. Go back to the question. Tell us what you did. Tell us exactly what you wrote. You just wrote 2 things there. You just multiplied by it. He said, I know the conversion. 1 mile equals 1.609 kilometers. And this is all he wrote on this page, folks, because he's done a few of these. And he goes, I know what to do here. Take 350 and just multiply it by the 1.609. I know there's more kilometers than miles. I can just multiply that. And he'd get, did you get the same thing? 563.15. So if you know what to do with the conversion, if you know whether to multiply or divide it, you don't need my common ratio method. You could just multiply. Any questions there? You've got an expert among you, by the way. So you've got a bunch of rulers there where you've got to do some ruler ones, and then you've got a bunch of conversions on the back page to try. Some of them get harder, some of them get easier.